To determine the total connected load service requirements for the building, firstly, let's calculate the lighting load. Assuming 60 watts per fixture and 25 fixtures, the total lighting load is 1300 watts. Secondly, for the ceiling fans, assuming 60 watts per fan and 25 fans, the total ceiling fan load is 1500 watts. Thirdly, for the refrigerators, assuming 1000 watts each and 3 refrigerators, the total refrigerator load is 3000 watts. Fourthly, for the washing machines, assuming 500 watts each and 2 washing machines, the total washing machine load is 1000 watts. Fifthly, for the water circulating pumps, assuming 750 watts each and 4 pumps, the total water circulating pump load is 3000 watts. Sixthly, for the microwaves, assuming 1200 watts each and 3 microwaves, the total microwave load is 3600 watts. Finally, the existing building load is calculated by assuming 80 amps times 240 volts times 3 phases, which equals 48,000 watts. The total connected load is the sum of all these loads, which is approximately 59,600 watts. To determine the minimal size generator, it's necessary to derate the generator capacity by 20% to account for efficiency losses. Therefore, 80% times 59,600 watts equals 47,680 watts. Rounding up to the nearest available generator size, a 50,000 watt generator, which is equivalent to 62.5 kV amps, would be suitable. Now let's consider generator sizing without the air conditioning loads. The air conditioning units account for 32,000 watts. Subtracting this from the total connected load of 59,600 watts, we get 27,600 watts. Derating the generator capacity by 20%, we have 80% times 27,600 watts equals 22,080 watts. Rounding up to the nearest available generator size, a 25,000 watt generator, which is equivalent to 31.25 kV amps, would be suitable for emergency backup without air conditioning loads. For access to Australian and international code books, the AS/NCS 3000 wiring rules is the Australian electrical code book, and it can be purchased from Standards Australia at www.standards.org. Additionally, the International Electrical Code (OIC) is an international codebook that is widely recognized and can be purchased from the International Electrical Commission at www.ich. The connected load calculations are estimates based on the provided assumptions. Actual loads may vary depending on the specific equipment used and usage patterns. It is recommended to consult with a qualified electrician to perform a detailed load calculation and determine the appropriate generator size for specific needs. The main breaker size will depend on local regulations and the calculated total load. The NEC National Electrical Code is not applicable in Australia. The AS/NCS 3000 wiring rules provide guidance for electrical installations in Australia and New Zealand. Always consult the latest edition of the applicable code for specific requirements. Estimating the loads of different equipment types requires understanding their power consumption. For lighting, the power consumption depends on the type and number of fixtures. Fluorescent lights are more energy efficient than incandescent lights. Ceiling fans consume power to run the motor that turns the blades. The wattage can vary based on size and speed settings. Refrigerators consume power intermittently as they cycle on and off to maintain the desired temperature. The power consumption depends on the size, efficiency, and usage patterns. Washing machines consume power for the motor that agitates or spins the clothes, as well as for any water heating elements. The power consumption depends on the type of machine and the wash cycle. Water circulating pumps consume power to move water through a system, such as for heating or cooling. The power consumption depends on the size and flow rate of the pump. Microwaves consume power to generate electromagnetic radiation that heats food. The power consumption depends on the power level and cooking time. Air conditioners consume power to cool air by circulating a refrigerant through a compressor and heat exchangers. The power consumption depends on the size, efficiency, and cooling load. Existing building loads may include a variety of electrical devices and appliances. Estimating this load requires knowing the types and power consumption of these devices. Generators are typically rated in kilovolt amps or kVA, which is a measure of apparent power. The actual power, or kilowatts, is the power consumed by the load, while the reactive power is the power that oscillates between the source and the load. Power factor is the ratio between the real power and the apparent power and is a measure of how efficiently the electrical power is used. A higher power factor indicates a more efficient use of electricity. Generator sizing should consider the total kVA load, the power factor of the load, and any dirting factors. Dirting factors account for the generator's altitude, temperature, and other operating conditions. It is important to select a generator that is appropriately sized for the load to avoid overloading or underutilization. Overloading a generator can damage it and cause it to fail. Underutilizing a generator can lead to inefficient operation and reduced lifespan. When sizing a generator, it is important to consider the starting current of motors and other inductive loads. Motors can draw a large amount of current when they start, which can cause the generator to overload. To avoid this, the generator should be sized to handle the starting current of the largest motor or combination of motors that are likely to start at the same time. Automatic transfer switches, or ATS, are used to automatically switch between the utility power and the generator power in the event of a power outage. ATS can be programmed to start the generator and transfer the load automatically, ensuring a seamless transition to backup power. Uninterruptible power supplies, or UPS, are used to provide continuous power to critical loads, such as computers and servers, in the event of a power outage. UPS typically use batteries to provide power during short outages. For longer outages, a generator can be used to recharge the batteries and provide extended backup power. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Generators should be properly grounded according to the applicable electrical codes. Regular maintenance is essential to ensure the reliable operation of a generator. Maintenance should include checking the oil level, coolant level, and battery condition, as well as inspecting the air filter and spark plugs. Generators should also be run periodically under a load to ensure that they are functioning properly. Before working on any electrical equipment, it is important to disconnect the power and follow proper safety procedures. This includes wearing appropriate personal protective equipment, or PPE, such as gloves and safety glasses, and using insulated tools. Only qualified electricians should perform electrical work. Electrical codes and standards are designed to ensure the safety of electrical installations. It is important to follow the applicable electrical codes and standards when installing and maintaining electrical equipment. The Australian and New Zealand wiring rules, or AS/NZS 3000, provide guidance for electrical installations in Australia and New Zealand. The International Electrotechnical Commission, or IEC, develops international standards for electrical, electronic, and related technologies. These standards are widely recognized and used around the world. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer for specific recommendations. The calculations and assumptions made in this explanation are based on the information provided and may not be accurate for all situations. Actual loads and generator requirements may vary depending on the specific equipment used and the operating conditions. It is important to perform a detailed load calculation and consult with a qualified professional to determine the appropriate generator size for a specific application. This will require a comprehensive understanding of all the electrical loads in the building, including lighting, appliances, equipment, and any other electrical devices. The load calculation should also consider the diversity factor, which is the ratio of the maximum demand to the total connected load. The diversity factor accounts for the fact that not all electrical devices will be operating at the same time. The generator should be sized to handle the maximum demand, taking into account the diversity factor. The generator should also be capable of handling the starting current of motors and other inductive loads. Motors can draw a large amount of current when they start, which can cause the generator to overload. To avoid this, the generator should be sized to handle the starting current of the largest motor or combination of motors that are likely to start at the same time. In addition to the size of the generator, it is also important to consider the type of generator. There are two main types of generators: synchronous and asynchronous. Synchronous generators are typically used for larger applications, while asynchronous generators are typically used for smaller applications. Synchronous generators are more efficient and can provide better voltage regulation than asynchronous generators. However, synchronous generators are also more expensive and require more maintenance. Asynchronous generators are less expensive and require less maintenance, but they are also less efficient and provide poor voltage regulation. The choice of generator type depends on the specific application and the requirements for efficiency, voltage regulation, and cost. When selecting a generator, it is also important to consider the fuel type. Generators can be powered by gasoline, diesel, natural gas, propane, or other fuels. The choice of fuel type depends on the availability of the fuel, the cost of the fuel, and the environmental impact of the fuel. Gasoline generators are typically less expensive than diesel generators, but they are also less efficient and produce more emissions. Diesel generators are more efficient and produce fewer emissions, but they are also more expensive. Natural gas generators are a good option if natural gas is available, as they are relatively clean and efficient. Propane generators are a good option if propane is available, as they are relatively portable and easy to store. The installation of a generator should be performed by a qualified electrician in accordance with the applicable electrical codes. The generator should be properly grounded and connected to the electrical system in a safe and reliable manner. An automatic transfer switch or ATS should be installed to automatically switch between the utility power and the generator power in the event of a power outage. The ATS should be sized to handle the full load of the generator. Regular maintenance is essential to ensure the reliable operation of a generator. Maintenance should include checking the oil level, coolant level, and battery condition, as well as inspecting the air filter and spark plugs. The generator should also be run periodically under load to ensure that it is functioning properly. The information provided is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer for specific recommendations regarding generator sizing, installation, and maintenance.